Hi everybody, it's Miss Austin and I'm going to be going over the Unit 4 Lesson 11 practice problems. Number 1, select all expressions that are equal to log base 2 of 8. So first I just mentally figured this out, right? That means 2 to what power is 8? I know the answer to that is 3. And so now I'm going to go through and figure out which other problems have an answer of 3. Does 5 to the third power make 20? No. Does 5 to the third power make 125? Yes. Is 10 to the third power 100? No. 10 to the third power 1,000? Yes. 3 to the third power? Yes. So all of these, I guess I could write it here, right? The answers to these are 3. 10 to the third power 1/1000? No. Which expression has a greater value, log base 10 of 1/100 or log base 2 of 1/8? Okay, well, 10 to what power makes 1/100? All right, I see the 10 squared makes 100, but it's the reciprocal, so I know the answer to this is -2. And 2 to what power makes 1/8? -3. So this one's bigger, log base 10 of 1/100, because that's equal to -2, and this one's equal to -3. This one is smaller. Andre says that log base 10 of 55 is 1.5 because 55 is halfway between 10 and 100. So he's using this idea that the log base 10 of 100 is 2, and 55 is halfway between, here I'll show you the 1, log base 10 of 10 is 1. So 55 is halfway, between 10 and 100. That is true, but that isn't how exponents work. And how could I double check? I could just check. Is 10 to the 1.5 power 1 or 55? Is that true? Let's use our calculator and check. Is 10 to the 1.5 55? No. Oops, sorry. It's 31. It is not equal to 55. Okay. Number 4, I'm skipping. It was from a previous lesson, but I just didn't want to focus on that today, and it has a lot of algebraic work. So number 5, how many times does $1 need to double in value to become $1 million? Explain how you know. So starting with $1, I want to keep multiplying it by 2. That's what doubling means, over and over again. Now, I could sit here and I could make a table, right? I could start with 1, and then I could double it, and I'd have $2. Then I could double it, I'd have 4. Then I'd double it, I'd have 8. And I'd double it. Okay, I could keep doing this. This would take a while. If repeated multiplication of 2 is just powers of 2. Let's put an N there. How many times do I have to do this to reach $1 million? I'm just going to guess and check until I can find this, right? Or you could rewrite it as a log, right? And the 1 doesn't really matter, right? 2, how many times till I get to 1 million? Let's try 10. 2 to the 10th, I'm at 1,024. 2 to the 15th, I'm at 32,758. 2 to the 17th, 131. Getting closer. 2 to the 18th, 2 to the 19th, 2 to the 20th. There we go. We're finally, so it needs to double 20 times to get a little bit. The 19th time I was only at 524,000. So 2 to the 20th gets me 1,048,576. Now, how would I write that as a log? Just out of curiosity, right? This is original problem. Log base 2 of 1 million equals, I don't know. That's how basically what that's saying is a log. And it would probably come out as a decimal, and we were just looking for a whole number. How many times would I have to double it? So I'm going to stick with my answer at 20. What value could you replace the question mark with in these equations to make them true? 10 to the what is 10,000. Remember your powers of 10. You could do this mentally, right? 1, 2, 3, 4. Today we also learned how to use our calculator for log base 10 of 4. You can just type on your calculator log 10,000. I'm going to keep encouraging mental when I can. Log base 10 of 10 million. 1, 2, 3, 4, 5, 6, 7. 10 to the 7th power is going to give me 10 million. 10 to the what? Or, ooh, now they're giving me the power. Sorry. 10 to the 5th would be what? That would be 1, 2, 3, 4, 5. 100,000. 10 to the 1 is what? 10. That's what would go in that spot right there. All right, number 7. What value of t would make the equation 2 to the t equals 6 true? Right, so basically log base 2 of 6 is t. The answer to that is going to make it true. I could go to my table that we had from the other day. I did have my log base 2, right? Here's 6. I have to raise 2 to the 2.5850 on my table. T needs to be 2.8580. And I could check with that. 2 to the 2.8580. What, did Miss Austin write that down wrong? Oh, 2.58. Good thing I checked. Wrote it down wrong. Try that again. 2 to the 2.5850, 6. Yep. Between which two whole numbers is that value? Well, I mean, I looked on my table. The number 2.5 is between 2 and 3. If I hadn't looked this up, I mean, let's look. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. I was looking for when it was going to be 6, right? Which is in between these two numbers right here, the second and the third power. Number 8. For each exponential equation, write an equivalent equation in logarithmic form. So this is log base 3 of 81 is 4. Log base 10 of 1 is 0. Log base 4 of 2 is 1/2. Log base 2 of 5 is t. Log base m of c is n. All right, guys, I hope that helped, and I will see you soon.